Hi, ladies. Welcome to Friday. It's the end of a week. Thank goodness it's Friday. Well, it's Friday while you watch this. I'm actually recording it on Thursday. Definitely a busy week. We've done quite a bit in this class, and I'm hoping that you're feeling pretty good. It looked like the survey results were pretty positive, so I'm feeling really good about that. A couple things that we're going to go ahead and get started with today. So, normal general outline as we normally have with the prayer, some updates, prime time today, going over some answers. We're going to talk about weighted mass averages. I've got a little project for you to do over the weekend. So I want to go ahead and get started, but first thing I want to do is I want to show you some of the prayer requests that are up here. We've had a few more people adding some prayer requests, and I think that based on a lot of the questions that I've been getting, there's a lot of questions about our future. And I know when we left class way back when, can you believe that it was the last day that you took Iowa testing? Wait, can you even remember that? That we thought that this would be a short-term thing and we'd be home and things would settle down and we'd come on back to school and everything would kind of resume to normal. And now there's a lot of uncertainty as to when we do resume things, what is this new normal going to look like? So the future for our lives, what we're doing, what school's going to look like, everything. There's so many things that are unknown. So, and we definitely have people in our community whose families are struggling with the coronavirus, with financial difficulties due to not being able to work, with a lot of uncertainty and a lot of instability. So everybody kind of keep each other in your thoughts and prayers. If you yourself or somebody that you know is really going through a rough time, and they need a reach out, let somebody know. Let somebody at Beaumont know. We're trying to keep an eye on the people that we know are having some issues and reaching out extra to them. I've actually been in contact with some of my former students. So, ladies, if you do know somebody who needs some extra prayers or needs a reach out, please share that with some of us so we have some awareness. So our prayer for today is kind of a different one. I found it online and I kind of looked at it and thought, oh, this is kind of a nice way to start the day. So if you'd pray with me, in the name of the Father, the Son, and the Holy Spirit, amen. Thank you for loving me, for walking with me, for caring about the smallest details in my life. Fill me with grace, Lord, that I may have the strength to face what is before me today. I do not know what today will bring forth, but make me ready, Lord, for whatever it may be. In the name of the Father, and the Son, and the Holy Spirit, amen. So, class update, fairly short today. Math video, I'm working on more. I've emailed a few of you because you might have been the only person or only one of two people who were requesting a particular topic, and I'm trying to get a little bit more information. Working on a few other things, so there will be more of those coming out over the weekend. None of them are mandatory. They are there to help you, only to help you if you have difficulties, questions, concerns. And some of that will be more obvious as you see your Chapter 2, Part 2 test, which I'm halfway through scanning. It is taking a long time. It is a long process to scan all 50 of these. But I am expecting to finish up over the weekend and then get them mailed to you or emailed to you. Next curation project due date is like right around now, but I'm asking you guys to wait until we finish Chapter 4 so you really have enough content to put in your curation project. I was asked about when we are able to get back to school, can you guys get your goggles? I believe the answer to that will be yes, but I'm not the one making the decision. However, most students do leave their goggles in my classroom and we get them to the teachers for next year. So assuming we return to the building, Mrs. Hamrick and Mrs. Iskander are the teachers for next year. Then we will just have you guys get your goggles in the fall and take those to the room. So you guys are welcome to leave those in my classroom. There is no need to worry about your goggles. If you're not coming back or not returning to Beaumont in the fall and you're transferring some other place, definitely arrangements can be made for you to grab them. So other thing is there are so many of you who filled out this last survey, and all the survey responses are really, really helpful to me in figuring out what I'm doing and where you guys are stuck and giving me a little bit more connection to you guys and kind of know what's going on. And a number of you who have taken some opportunities to write some very kind words to me, and I wanted to tell you that I really appreciate it. I am doing this in such a bubble, not knowing how you guys are doing. I can't see your faces. I don't know when you understand. I don't know when you're lost. It makes it really challenging to try to teach to my computer screen. I'm doing the best that I can, and based on your feedback, it sounds like a lot of things are going really well. I'm relieved to hear that, and I'm also very appreciative of all the people who've sent me some really kind words. So thank you very much. It means a lot to me. So just know that that's very much appreciated, even though I may not see you individually or talk to you individually, at least not right now. So I've had a number of questions. How are my dogs doing? They're doing better. We're still not allowing them to have like run of the house or be able to be by them together out in the common area because we don't 100% trust them. They are much, much better than they were. The trainer's pleased. We've made great strides, but there's still a little bit of fear in our own minds as to if we let them together, are they going to fight again and draw blood? And we certainly don't want that. So we're still working with them, but I feel like I can see the light at the end of the tunnel. So that's a really good thing. So thanks for asking. I've also gotten a couple of questions about my own health and how am I doing. So far I'm okay. I'm healthy, haven't been sick. As I shared with you guys on the last day, you know that I have this immune deficiency and it's pretty serious, but I normally am able to manage using my monthly treatments. And I actually have one next week on Tuesday. Yeah, and that'll be the second time the nurse has been here since this is really broken out. So it's kind of interesting because she's like all gowned up and masked up and everything. It's kind of weird. But I'm okay, and the future for me is very, very uncertain. Not sure what's going to happen to me in the future and if I'm going to be able to really safely go back out in public, which also means I don't know about returning to school in the fall. And I've let administration know that because I just don't know. On top of that, my immunologist is retiring at the end of the month, so I'm finding a new doctor to work with, and I see him in May. And right now, the experts don't have a whole lot of the answers, and really, until a good portion of the community has either seen the virus, recovered from the virus, and we've got this herd immunity going on, or we've got a vaccine, I am not safe. Because I really rely on that to kind of protect me and prevent me from getting ill. But I don't know what that looks like. And for right now, I figure I'm going to try to be as positive about it as I can and recognize that at least for the next month or so, I'm doing the same thing I've been doing. And I'm just kind of go on with that. And I have this other band video, which I'm looking at the time right now, and I've already chatted for quite a bit. So I may show it back here at the end, but a number of you know that I play in a couple of local community bands, and one of them ended up doing a video song together where one person took the audio from all of us who were playing and superimposed it and kind of overlaid it and produced a video. So if I have a chance, I'll put it right at the very end of the day. So a couple other things. I wanted to show you a little bit more about Singapore. I've got a few questions from people, and there was a couple things that I really wanted to show you. So first of all, I wanted to show you what the wet market look like. This was in one of the Chinatown areas in Singapore. And so this is my daughter. This was a number of years ago, so she's quite young with a really short hair. The wet market is called a wet market because it is set up so that it can be hosed down with a water hose, garden hose, every day. And a lot of times the floor is wet as a result of that. So you can kind of see here from some of the pictures, this is part of the area. There's fish laid out here on ice, and there's a lot of other food. You can see a lot of fruits, fresh fruits here. This is another part of the market. I believe there were like herbs and spices. Here we've got some other food, vegetables, produce, meats. The butcher looks very much like the fish area here. But this is kind of what a wet market looks like. And I thought that with everything, with how this coronavirus started out, that it would be interesting to you guys to see what this looked like. And when we lived in Singapore, there were a lot of fruits that I had never seen anything like them before. So they were just odd looking. We've got dragon fruit, we've got jackfruit, rambutan, mangosteen, durian. Okay, durian is a special thing all on its own. Durian is really well known in Singapore. It really stinks. It's awful. It smells like rotten eggs on steroids. Durian is outlawed in a lot of places because it smells so horrible. But people who eat it love it. They say it's great. And I'm thinking, I don't know how you can get past the smell. But that's what durian is. It looks like this. It's got like all these little spiky kind of things out. And one thing that we used to do was we used to go to stalls like this in one of the food markets that we could get fresh squeezed juice. And all of these unusual fruits and lots of normal fruits you can get squeezed into fruit juice. And our favorites were fresh lime juice, which is not lime juice. It's different. It's fresh lime. It's a different fruit. It's similar to lime, but it isn't the same thing. And then dragon fruit and mango. So we used to go and get those fairly regularly. I had mentioned last time that Singapore is a melting pot of a lot of different cultures, which makes it really interesting. So this is a Chinese temple. It's a Buddhist temple, and they had a tooth, part of Buddha's tooth, and it was a relic area. Kind of see what this looks like. This is in the Chinatown area, very close to where that wet market is. This is an Arab mosque, so it's called Sultan Mosque. It's on Arab Street, and these are some of the panels that are inside there. It's very nice. It's really beautiful. This trip, my family didn't go inside. I'd been inside a couple times previously. Here is a Hindu temple, and it's called Sri Mariamman, and it's very unique. Lots of sculptures that are visible from the outside. This is like the main gate. These are like on the corners of the building, and it's like right in the middle of everything. I mean, it's just like plopped down in a neighborhood, right where everybody lives. There were lots of beautiful paintings on the ceiling, lots of sculptures, things that are very unique and different to me. And I had really not been very knowledgeable about these different religions and some of the things that came with their cultures. But this is a little bit of what you can see in Singapore. And as you can see, there's quite a bit of diversity in the religions that are there. So moving back on to our topics for the day, we're still in the middle of isotopes, where we're going to talk about them some more and a little bit more about periodic table groups. But we're progressing pretty well through chapter 4. So your prime time today is another coloring sheet. It's page 24. And if you didn't catch it last time, you did 25 last time, which has a different key up here, and it was metals, nonmetals, and metalloids. And here we've got a different way of separating the periodic table of elements. And so today what I'm going to ask you to do is color it in. again, your colors do not have to be the same as what are here, and you use what you have however it works. I do want to note that it's really hard to see that these 2 rows down here on the bottom, they are not the same color. This top one of the bottom rows is actually brown, and it's this one. It's the lanthanide series, and it starts with an element symbol La. And this bottom one is the actinide series, and it is black or gray, and so it starts with that element out here in the front. So know that that's actinium, I believe. So know that these 2 lines are different colors. So pause this and take a look and color this in. Just make certain that whatever colors you have for like this column here, and that you label it the same in your key. So I have a short video today. It is on the drinking bird. So some of you who have probably seen these little drinking birds before. This is a lot like the hand boiler demo that I showed on a video a couple weeks ago. All right, so that is how the drinking bird demo works. You may have seen one of those previously before. I would have shown you mine in class, but this video does a really great job, so I decided I'd use that. So let's go over our homework that we worked on last time. So last time we worked on green page 15, and I did numbers 1 and 2, and I left you to do 3, 4, 5, and 6. So for number 3, the one on the left, 18 protons plus 22 neutrons equals 40, so the atomic mass is 40, and the atomic number is 18. Looking at the periodic table, we can see this is argon. When we count the electrons, we see there are 18, so it's a neutral charge. Number 3 on the right, 17 protons plus 18 neutrons is 35, so that's the atomic mass. 17 is the atomic number, so going to the periodic table, we can see that that's chlorine. Counting the electrons, there are 17 of them, so they're the same as the number of protons, and there's no charge. And these two are different elements because one is argon and one is chlorine, so they're atoms of different elements. Number 4, the one on the left, 16 protons plus 16 neutrons equals 32. That's the mass, and 16 is the atomic number. Going to the periodic table, it's sulfur. When we count the electrons, there's 16, so there's no charge. And then number 4 on the right, 16 protons plus 18 neutrons is 34, so that's the mass. 16 is the atomic number, and it's sulfur. We count the electrons, there's 16, and there's no charge. So these two are both sulfur, so they are the different isotopes of the same element. Number 5. On the left, there's 1 proton and no neutrons, so the mass is 1 and the atomic number is 1, so that's hydrogen. On the right, there's 1 proton and 1 neutron, so that equals 2, so the atomic mass is 2. Atomic number is 1, that's also hydrogen. So, and there's 1 electron for both of these, so it's they're both neutral, and these are the same elements, different isotopes. So number 6. On the left one, we have 19 protons and 20 neutrons, so that adds to 39, so that's the atomic mass. And then 19 is the atomic number, so looking it up on the periodic table, that is potassium with the symbol K. So when we count the electrons, there's actually 18. So 18 electrons and 19 protons. This is not a neutral charge. So there happens to be 1 more proton, so 1 more positive charge than there are negative charges. So overall, the charge will be positive 1. And you can see how this is actually written in the key. It is written as a superscript over on the right-hand side. On the right, we have 20 protons, 20 neutrons. That sums to 40, so that's the mass. And 20 is the atomic number, so that's calcium. And again, counting those electrons, we get 18. And this is not a neutral charge, so there's 20 protons, 18 electrons, meaning that there are 2 more positive charges than negative charges. So the overall charge will be +2, and you can see how they write that in the key. So we're going to be discussing in the next class these charges. So it's okay if you're not 100% comfortable with just these 2 examples here right now, but I wanted to go ahead and introduce this information today and at least hope that this explanation makes some sense to you now, and we'll be doing more with those charges next time. So then there's green, page 16. I did lines 1 through 5 and 9 last class, so I want to go over the ones that I did not do in class. So line 6 is down here. We're given protons equals 29, neutrons is 36. So the atomic number is 29, means the element is copper. Atomic number, or atomic mass, is 29 plus 36, which equals 55. So from that, we can write the isotope notation and the standard notation. And the neutral charge is such that, so we end up with electrons and protons equals 29. So then line 7, we're given Se-78. So the atomic mass is 78. From the periodic table, we can see that Se is atomic number 34. So that's the number of protons as well as the number of electrons because it's neutrally charged. The number of neutrons equals the atomic mass minus the number of protons. So that's 78 minus 34, which equals 44. And now you can write the standard notation. Line 8, we are given Kr, and the atomic number is 36, and the atomic mass is 86. So protons equals 36, which equals also the number of electrons. Number of neutrons equals 86 minus 36, which is 50. and then we can write the isotope notation. Line 10, we're given the atomic mass of 81 and the number of neutrons is 46. The number of protons equals the atomic mass minus the number of neutrons, so that's 81 minus 46, which is 35. And the number of electrons equals the number of protons, which equals 35, which is also the atomic number, so we can look it up and find that this is bromine. So we can then write the standard notation and isotope notation. So then line 11, we're given U-235. So we know that the atomic mass is 235. Looking at the periodic table, we can get the atomic number of 92. So the number of protons equals the number of electrons, which equals 92 because it's neutrally charged. The number of neutrons equals the atomic mass minus the number of protons. So that's 235 minus 92, which gives us 143. And then you can write the isotope notation and standard notation. Next line, we are given the atomic mass is 204 and the number of neutrons is 122. So the number of protons equals the atomic mass minus the number of neutrons. 204 minus 122 equals 82. The number of electrons equals the number of protons, which is 82. It's neutrally charged. That's the same as the atomic number, so we can find out that it's lead. And we now can write the isotope and standard notation. Then line 13, given the atomic mass is 204 and the number of neutrons is 124. So the number of protons equals the atomic mass minus the number of neutrons, 204 minus 124, which is 80. That also is the number of electrons, the number of protons, the atomic number, telling us that it's mercury. So then you can write the isotope and standard notation. And then the last line on our chart here, we're given the protons is 76 and the number of neutrons is 114. So the atomic mass equals protons plus neutrons, which is 76 plus 114, which is 190. The number of electrons equals the number of protons, because it's neutrally charged. It's equals 76. It's the atomic number, and it is osmium. So now you can write the isotope and standard notation. And from all of that, once you've colored in all of the symbols and all the numbers that you are in this table up here, you should end up with this message here, equals E equals MC squared. So today we're going to talk about how we get the atomic masses that are listed on the periodic table. So we're going to start on page 19, and there's some things for you to fill in as I go along. This is a similar kind of worksheet that we've used in the past. So remember that the mass number equals the protons plus the neutrons. Isotopes are atoms with different numbers of neutrons. And atomic masses occur with decimal points because they are an average of different isotopes. It's very rare that an average of a bunch of numbers ends up being exactly a whole number. So the atomic mass units are defined as 1/12 of the mass of a carbon-12 atom. So that is a carbon atom that has an atomic mass of 12. And that is the way that atomic mass is measured in the periodic table, and we abbreviate it as AMU. So that stands for atomic mass units. So to find the atomic mass, you need to know the number of stable isotopes, the mass of each of those isotopes, and the natural percent abundance of each isotope. So what does this weighted mass average have to do with anything that you might have seen before? So you've actually seen this more often than you probably realize, because most of the time your grades are made up of something that is a weighted average. So if you are in a class and it says that your tests are worth 70% of your grade, your quizzes are worth 20% of your grade, and your homework is worth 10% of your grade, and you earn these grades that are listed here, how do you find out what your grade is? So the way you do that is you take each of your percentages that the percent of your grades, your test was worth 70% here, and you multiply that by your test grade, which was 80, and then your quiz grade was 20% and you had 100, and your homework was 10% and you earned 100. So when you take each of these things, multiply them together, add them all up, you get an 86%. So it's really important that all your percentages must sum to 100%. Otherwise, something is not quite right in your calculation. And if you're writing them as decimals, like they did here, 0.7 plus 0.2 and 0.1, that also sums to 1. So continuing on to the back of this page, you're on page 20 now. You have to find the atomic mass. So the atomic mass of an element equals the atomic mass of the first isotope times the percent of that isotope divided by 100 plus the atomic mass of the second isotope times the percent of that second isotope divided by 100. So we're going to do a bunch of examples with that so that you get quite a bit of practice today. So the first example is chlorine. Calculate the atomic mass of chlorine if the two common isotopes of chlorine have masses of 35.45 atomic mass units with 75% abundance and 37.29 atomic mass units, and that one's 25% abundance. So if you set up your information like this and you do this fairly consistently, it will kind of help keep it organized. So that on your sheet of paper, they have it set up here. So the first atomic mass of the first isotope is 35.45 AMUs, and the percentages is 75.00%. And I recommend that you put the 0.00 because these significant figures are going to be important as we're doing this math calculation. The atomic mass of the second isotope is 37.29 AMUs, and that percentage is 25.00%. So the math and the way this works out is 35.45 AMUs times 75 divided by 100, which they've shortened this as one step, which is 0.7500, plus 37.29 AMUs times 25 divided by 100, which is 0.25. This person showed us each of these multiplication answers here, and so when we get to the bottom, we get 35.91 AMUs. You see here we have 4 significant digits in all of our numbers, so our final answer, we want to have 4 significant digits. And the units on here is atomic mass units. So there is a spot for that on your sheet. It says atomic mass of chlorine equals blank. You can write that number there. The next problem on your sheet is, what if you don't have all the percentages or the atomic mass? So we're only going to do part of this problem, but we'll go ahead and get it started. So calculate the atomic mass of one of indium's isotopes, because there are 2. If the atomic mass of indium is 114.8200 AMUs and one isotope has a mass of 114.9041 AMU and the abundance is 95.795. So we've got this information here. We know that the atomic mass of indium overall is that 114.8200 AMU, and we can write down the information given for the first isotope. We also can figure out that the percentage of the second isotope, because there's only 2, since it's got to sum to 100, is going to be 100 minus this number, which gives us 4.205%. So now it is possible to use algebra to determine what this atomic mass is for the second isotope. I normally do that in class, but due to the fact that I've got some limited time constraints, and I think this is one of the harder things for us to do, I believe that we will struggle a lot working on this. I am going to skip this part. If you'd like to copy this information and the answer down here on your sheet, you are more than welcome to. I'm going to show it up here. Because you basically end up with an algebra equation. You multiply the percentage times the atomic mass of the one isotope, and then the second one, you're going to use it as x, and ultimately you're going to just rearrange your equation and solve for x. But again, I am not going to worry about it. We are not going to be doing problems like this. If you feel comfortable with algebra and look at this and go, oh, this is okay, I can write this down, that's great. If you don't, do not worry about it. So I want to do some more examples. So moving on to page 21, we have number 1 here is set up very similarly. Calculate the atomic mass of carbon if the 2 common isotopes of carbon have masses of 12 AMU, 98.89% abundance, and 13.003 AMU with a 1.11% abundance. So I've filled in my table, very similar to the other ones. I stopped to make certain that they do sum to 100% with adding these percentages, and they do. If I look at my sig figs, there are 4 and 5, so I'm going to want 4 sig figs in my final answer. So the atomic mass of this element, which is carbon, is going to be the atomic mass times the percent divided by 100, plus the atomic mass of the other isotope times the percent divided by 100. So writing this down, I've got 12.000 times 98.89 divided by 100 plus 13.003 times 1.11 divided by 100. And when writing it like this with this information in the table like this, you're just copying these numbers and bringing them down here, and you're copying this column and putting them down here. Or alternatively, you can write the 98.89 divided by 100, and you can start out writing that as a decimal. Either way is fine. I do notice that sometimes when we end up with things that are really small percentages and you divide them by 100, students can sometimes make mistakes with that. But if you're comfortable with the math, you're welcome to do it either way. So when you do the math here, I find that the atomic mass of carbon is 12.01 AMUs, and that is 4 sig figs. So moving on to number 2, calculate the atomic mass of nitrogen if the 2 common isotopes of nitrogen have masses of 14.003 AMU and that abundance and 15.00 AMU. So with this one, I'm going to do the same thing. I've set it up just the same. Sig figs, there's going to be 4. I've got 4 here. Oh, I've only got 2 here, so I should really only have 2 in my final answer. Okay, so I fixed that. So we have 2, want 2 in our final answer. So we're multiplying our atomic mass here times the percent abundance. Add that to the other atomic mass times its percent abundance. Notice that when I take 0.37 divided by 100, I end up with 2 zeros here in the front. So when I do the math, I get 14.01 AMU, and with the sig figs, that would be 14.0. And ladies, if you're not using your calculator and punching these numbers in along with me, you might find the problems that you have to do on your own to be very challenging. So I do suggest you do try to do these problems and punch the numbers in, make certain that you're getting the same answer. So number 3, calculate the atomic mass of oxygen with the 3 common isotopes have these masses and percent abundances. So this time We now have 3 of them, but we're doing the exact same thing. They do sum, the percentages do sum to 100%. Sig figs, we've got 2, 3, and 5. So in our final answer, we're going to want 2 of them. So the atomic mass times the percent abundance plus the other atomic mass times the percent abundance, and the third atomic mass times the percent abundance. Notice this time I did the division by 100 already before I typed all this stuff in. So notice here that when you divide these by 100, you've got to be very careful about how many zeros you have here. So I ended up with 15.999 AMU, and then before I round, and at the end, I get 16 AMU. So if you turn the page over to page 22, I'm going to have you do number 4 on your own, which is very similar, only this time it has 4 isotopes. And you can cross out problems 5 and 6 because these are ones that you'd have to solve for X using an algebraic equation, and I don't want to do that with you guys. So you can cross out number 5 and 6, but pause the video and do number 4. So we're also going to back up in your packet and look at page 18. Take a moment and read numbers 1 and 2 and see if you can answer these on your own before I give you the answers. So number 1, what is the difference between one isotope of an element and another isotope of the same element? Hopefully you recognize that it has to do with the number of neutrons. And number 2, if isotope number 1 has a percent abundance of 25% and isotope number 2 has a percent abundance of 75%, the average atomic mass will be closer to which isotope's mass? I'm hoping that you recognize that it will be isotope number 2, since that is the one that it's a higher percent abundance. There is more of that in existence. So there are 3 average atomic mass calculations on this page. I'm going to do number 3 with you. And I want to point out at the beginning, it says here that with instructions to be sure that you round to the nearest thousandth. So for these, it wants you to round to the nearest thousandth at the end of your problem. So while we are not really paying attention to significant figures the way we normally do, because it has told us that this is what they want us to do. So just remember, when they give us this notation, this standard notation, the atomic mass of this version of hydrogen is 1, and the percentage is 91.75. The atomic mass of this other isotope of hydrogen is 2, and the percent abundance is 5.85%. Now, I just want to note that these do not sum to 100%. Tells us that there's either an isotope missing or there is a mistake here. I do recognize that, but I'm going to just use the problem as it is for now because I think fixing it to be correct is too complicated. So I just want to note that they do not sum to 100%, but we're going to do the math anyway. So for this one, we're multiplying 1 times that 0.9175, and adding that to 2 times 0.0585, and you would end up with 1.0345 atomic mass units. So numbers 4 and 5 are very similar to this. One has 3 isotopes of potassium, and I know that in the problem statement it says, what is the average atomic mass for the element iron? But then it gives you the symbol for potassium. I realize there's a typo there. But you can still do the problem. And then the last one has 4 isotopes of iron. So go ahead and pause the video and work on those. So the other part of your homework over the weekend is going to be talking about this candy project that I have been alluding to for the last couple classes. Okay, so I'm going to ask you guys to make 2 models using the candies over the weekend. Everyone's going to be assigned 2 isotopes of the same element to make a model of. And your models are going to actually look very similar to page 15 in the green packet. So you're going to need to determine the number of protons, neutrons, and electrons and record these on your paper. And how you do this is kind of up to you. If you want to use candy, that would be great. This is how I would normally have done this in class because it's kind of fun and just kind of different. If you don't have any candies available and you want to use colored markers, I'm okay with that too. They do need to be clearly seen. So when you are looking at putting all of these protons and neutrons in your nucleus, we have to be able to visibly see them and count them. I ended up doing one on my computer as an example, as well as one with candies, so you can see what I'm talking about. Either way, whichever way you want to do this is totally fine with me. So just remember, in the nucleus, you want a circle in the center, and you're going to put all your protons and neutrons. In your electrons, you're going to divide them up kind of like what they did on the one page in your packet, which was page 15. So in the first circle outside of the nucleus, you're going to put 2 electrons. And then in the next circle, you can put a maximum of 8. And any additional circles needed can have a maximum of 8. And you're going to do that until you've put all of your electrons into the circles. Now, I know we haven't talked about all of that, and we haven't worried about that, and you're going to do more of that next year. But I figured since I was going to have you make these models, we might as well try to make them as close to correctly as possible. So if you're doing this on a piece of paper and you need to trace a cup, a glass, a dish, or something to have circles, do that. If you want to do it on the computer and have it on that, that's fine. Either way, I do kind of like the candies because they're kind of fun and they're easily moved around for future work and you can reuse them. And we are going to be using these again. So well, however you do this, don't throw your stuff out. I actually put the candies that I used in a little Ziploc bag, and I'll just reuse them again for the next time that we're going to be doing some of this. So here's an example. I did an isotope of oxygen, number 16. So looking at the periodic table, I found that it is number 8. So it has 8 protons, 8 electrons, and by taking 16 minus 8, I knew that there were 8 neutrons. So I picked 3 colors and started placing them where I needed to. So the protons, there are 8 of them, and I put them in here in this nucleus. I shaded it in just so I could see it more easily. And it shows up really better when I did the candies. The neutrons, they're also 8, and I put 8 dots in here. I kind of randomly scattered them because it was just easy to do digitally, but that how they work out if you're doing candies, it doesn't matter. Just having the right number where they're supposed to be. The electrons, there are a total of 8 needed, and so the inner circle is going to have 2, and that means that I've got to place 6 more. So the next circle can hold 8, but I only need to put 6, so I'm only going to put 6 there. So 1, 2, 3, 4, 5, 6, so I have a total of 8. So what you're going to need to do is you're going to turn in a document or a photo that has something that contains all of this information. So you're going to need the isotope that you're doing, the number of protons, electrons, neutrons, as well as your model. So my other example. So here is another example that I did. This is the one using some candies. So I took oxygen 17, which is another isotope. So since it's oxygen, there are still 8 protons and there are 8 electrons because this is neutral. The number of neutrons is found out by taking 17 minus 8, which is 9. So I picked some green Tic Tacs for my protons, and those are 8. So there are 8 little green Tic Tacs here. I took neutrons being the white, so I've got 9 of them here, and this is actually why I shaded this circle in a little bit with just a really light gray, so it was really easy to see the white Tic Tacs. And then there are 8 electrons, and I used orange. So I've got 2 in the inner circle, and I've got 6 in the second circle, and that gives me 8. That's what I need. So for yours, be sure you turn in your 2 pictures or 2 documents, however you're working on it. So the assignments for you guys is you're going to find your birth month in the table below. And for each birth month, there are 2 isotopes that are assigned, and they're a little bit different from each other. I have some reasons for assigning these specific isotopes, so make a note of them. I will put this in a table also up on P-Learning, so if you forget to copy it here, you don't actually have to go through and watch the whole video one more time. So 2 isotopes for each student. Take a look at your birth month, and that's going to determine which 2 isotopes you need to do. And I'm looking for a document or 2 pictures similar to what I showed you. So polyatomic ions, again, kind of like last time, I'm not going to go over naming them yet. I am hoping that you've been working on the couple that I tell you each class. So if you are keeping up at the end of the weekend, you are going to be over halfway done. And so the 3 that I'm recommending for you guys to memorize before next class are chlorate, which is ClO3 with a -1 charge, chromate, which is CrO4 with a -2 charge, and peroxide, which is O2 with a -2 charge. And yes, this is part of hydrogen peroxide, which you guys are familiar with. So polyatomic ions, adding 3 more to your practicing list. Turn-in work, which is due Tuesday, which is the next time we have a B day. So you've got worksheets 18 through 22 and 24. Most of these we went through everything today. There isn't a whole lot that you need to do independently. And 2 candy models. In addition, please fill out the survey. I really am appreciating your comments and getting some feedback and learning a little bit about you guys at the same time. And I've just started looking at some of your book suggestions from the last one, so I appreciate it. And that's it. So chapter 4 book work, I've added section 4.9, which is the natural states of elements, which I'm only really going to briefly talk about next week, because again, I'm not covering everything that I would normally cover in the interest of time, and because I think that there are certain things that are really important that I do cover. Looking ahead, we're almost done with chapter 4, so just be aware that a test is going to be coming up. Your curation project, next links are going to be due when we finish chapter 4, because I wanted you to have covered enough material to make it worthwhile. Math videos, I'm working on them. Scanning chapter 2, part 2 tests, I'm still working on them. And I think that's everything. So ladies, have a wonderful weekend. I hope that you guys are feeling like you're getting kind of confident on this. I hope that the activity with the candies, or whether you're doing it digitally or not, goes well. If you do run into any problems as you're doing them, go ahead and send me an email. I will answer them as I have time. But ladies, have a great weekend, and I will talk with you next week.